Hello, everyone. This is the lecture for section 6.2, graphs of the other trigonometric functions. Okay, so in 6.1, I showed you all how to do sine and cosine and all its variations, right? Um, we're now going to do the other four. I know this is going to be a fair amount of stuff. You're thinking we're going to do all four, right, of the other trig functions, but it's not anything you haven't learned, okay? Two of them are going to be very similar, and the other two are going to be basically a review of how to graph sine and cosine. And that's it, okay? We'll start with graphing tangent first, okay? So there's one thing that I do have to make everyone recall really quick. Tangent is sine of a theta over cosine of theta, okay? Well, let me keep it with the notation that's given here. It's going to be sine of x divided by cosine of x, okay? This is back from section 5, from chapter 5, okay? Now, why do we need this is because we are going to be using this along with our unit circle to find the values of tangent, okay? Okay, and in particular, what we're going to concentrate on is this. The angles between negative pi over 2 and pi over 2, specifically these handful right here, these five. Okay? All right, so here we go. Okay? Let's take negative pi over 2. Okay? And I want tangent, right? This is equivalent to sine of negative pi over 2 divided by cosine of negative pi over 2. Okay? If you use your unit circle, right? This is going to be negative 1 divided by 0. This right here is does not exist. Okay? Okay. Let's keep moving on. I'll cover that in a second. Okay? The next one, negative pi over 4, right? That's going to be equal to sine of negative pi over 4 divided by cosine of negative pi over 4. Okay? And if you compute this out, again, using your unit circle, negative root 2 over 2 divided by the square root of 2 over 2. Okay, and if you compute this out, and put parentheses around there, if you compute this out, this is negative 1. Okay, moving along. When x is 0, this is going to be sine of 0 divided by cosine of 0. Okay, 0, 0, not theta, 0. Okay, this is equal to 0 divided by 1. This is something that's defined. This is equal to 0. Okay, moving on, pi over 4. Sine of pi over 4 divided by cosine of pi over 4. Okay, that is equal to root 2 over 2 divided by root 2 over 2 from the unit circle. This is equal to 1. Okay, and the last one, okay, this is equivalent to sine of pi over 2 divided by cosine of pi over 2. 1 divided by 0, we know we can't divide by 0, so this becomes a DNE again. Okay? So, this is what we get between negative pi over 2 and positive pi over 2. Okay? Now, how does this look like? Let me scroll down. Okay? We have the graph right here down below. Okay? And what we specifically did was we graphed this portion right here from negative pi over 2 all the way over to pi over 2. This little section of x variables on the x-axis right there. Okay? So if you guys see, right, these 2 points right here, you guys see that there's a two, actually let me put them in pink, there we go. There are two asymptotes, right? They are at pi over 2, negative pi over 2, negative pi over 2, and positive pi over 2. Those are my asymptotes. That's these. Okay? Those are my DNEs. You guys see my DNEs? Yeah. Okay? And then we have 3 points. We have this point right here, this one, and this one. Right? And those are exactly where you think they would be. Actually, let me move these around a little bit. Uh, This one, the x-axis, on the x-axis is going to be negative pi over 4. This one's going to be at 0, and this one's going to be at positive pi over 4. Let me write these back in. Negative pi over 2, positive pi over 2. Okay? There we go. So we just drew one period, just the one period, this one, of tangent. Now, I do need to expand a little bit because you guys see, hopefully, everyone sees, there's another, and there's another. There's a bunch of asymptotes that keep going in either direction, right? So, why that? Why is that? Why, right? So, let's take a look at f of x, right, being equal to tangent of x. We know that this tangent of x is going to be equal to sine of x divided by cosine of x. Okay? Now, if you remember from chapter, I think it was chapter 3, when we were learning asymptotes, right? How do we find asymptotes, right? Asymptotes happen, right, when the bottom is equal to 0. The asymptotes happen when the bottom equal to 0, right? That means, right, for this, that means that the cosine of x has to be equal to 0. Okay, now, I want you to look on your unit circle, okay, and notice that cosine is equal to 0 at negative pi over 2 and positive pi over 2, right? But if you start going around the unit circle over and over and over again, right, wherever it lands on negative pi over 2 or positive pi over 2, right, the cosine is 0. It's just extra spins around the unit circle, right? So this is where we get this, right? If this is true, right, therefore, right, x has got to equal not only negative pi over 2, right, and positive pi over 2, but all angles where x lands on either one of these two. Okay, so that means we can keep going around. Okay, so then that means 3 pi over 2 if we keep going in the positive direction, 5 pi over 2, 7 pi over 2, so on and so forth in that direction, right? And we can go backwards as well. I'm going to actually move this backwards. So then negative 3 pi over 2, negative 5 pi over 2, and I'm going to move this back even further. I'm just going to put dot, dot, dot. So long as your angle lands on any one of these, we get an asymptote. So long as your angle lands on any one of those, we get an asymptote. Okay? So that answers our next question, right? The tangent graph, the graph of tangent of x, right, has an asymptote. Whenever x is equal to any one of these values. I'm just not going to even write it anymore. Just stick it in right there. Sound good? Okay. Awesome. Okay, there is a fair amount of stuff for tangent. It's all sort of encapsulated in this little square. I'm pretty sure this square is going to be on everybody's flashcard for exam 3. Okay, so when you have anything that looks like this, right? This is the graph of tangent. This square, this box of info, right, has everything you need to know about tangent. The stretching factor, if you guys remember when we were talking about sine and cosine, that a value, okay? That a value is your stretching factor or your amplitude. And when we talk about it with tangent, it's not an amplitude, it's a stretching factor again, okay? Go figure, but you know what it does, right? The period is given by pi divided by b. So if you take a look at, let me scroll up again. If you take a look at this distance from here to here, right? You see that distance right there? That is exactly pi, right? And just like before, when you had pi, or when you had the period, when we were talking about sine and cosine, that period was 2 pi divided by b. Whenever we have something else other than 1 for b, this changes. This equation right here changes our period, okay? The domains. X can't be where we have an asymptote. We can't divide by 0. So that's the list there, okay? The range is negative infinity to infinity. So if you take a look at the graph again, right, it goes from down below all the way up to the heavens, right? So there we go. That's your range, okay? Vertical asymptotes are these right here. You compute this over and over and over again, right? And you get all of the asymptotes. Now, I want to bring up something for this, okay? But I'm going to do it once we get to an example, okay? There is no amplitude. Like I said, we have a stretching factor again, okay? And the last thing is that tangent is an odd function, okay? Because it is a quotient of odd and even functions, okay? So that's minor, okay? Let me erase all the highlights. Let me show you the most important thing of it all, and that's this thing right here. I'm gonna do it in yellow, or in orange, sorry. That right there, where k is an odd integer, okay? So this right here is gonna give us every single asymptote we want, okay? So long as we grab k, right, and plug in odd integers, okay? This is it. This right here is going to give us the graph, okay, without needing to graph it on a graphing calculator, okay. So what do I mean by that? Okay, let me scroll down, and let's say I wanted to graph this right here. Okay, I want to graph 2 periods of this thing right here. Okay, I'm going to use that equation that was up above, so vertical asymptote, to find them all. Okay, the vertical asymptote for tangent, right, is given by c divided by b, okay, plus pi divided by 2 absolute value of b times k, where k is equal to odd integer. Okay, so k has to be odd integers. Well, we can choose whatever k we want. I'm going to choose them in the order that makes most sense. I'm going to choose k equal 1 first. I'm going to compute something with that. Okay? Okay, so here we go. If k is equal to 1, I need my b. Ooh, now I made it nasty. Divided by b. Okay, I need my c and I need my b. There is no c here. If you guys see in here, right, there is no c, but there is a b, right? So computing stuff out, 0 divided by pi over 2 plus pi divided by 2 we do absolute value of b, absolute value of pi over 2 times 1, okay? Okay, if you simplify this out, 0 divided by whatever, that's going to be 0. Plus, right here, I'm going to get, what am I going to get? Pi divided by, hopefully you guys see this, I'm going to do the cancellation here. 2 times a half, that goes away, so I get left with pi divided by pi times 1. This is equal to 1. Okay. We have our first asymptote. Okay? Okay. We are done with k equal 1. That was our first odd integer. We're going to move on to the next odd integer, k equal 3. Okay, so I'm going to do the exact same stuff. I'm going to change this tail right here. That 1 is now going to become a 3. That's it. So x is equal to 0 divided by pi over 2. It's still the same c and b, right, from our equation, plus pi divided by 2 pi over 2 times 3. Okay, hopefully you guys see that the math is becoming repetitive, right? 0 plus, cancel those out, you get left with pi divided by pi times 3. That is going to be equal to 3. Okay. Hopefully you see something happening, okay? And this is what's going to happen every time, okay? Notice that I plugged in 1. I got 1. Notice that I plugged in 3 for k. I got 3, okay? Usually after the second one, usually after your second value that you plug in, okay, you start to see a pattern. Okay, the third time that you plug in your variable, your k value, should sort of solidify that pattern. Does that make sense? Okay, so I'm going to let you guys think about this for a second. So the next odd value is k equal 5. I wonder what my asymptote's going to be. Okay, let's compute it. X is equal to 0, well, 0, I said 0, 0 divided by pi over 2 plus pi divided by 2 pi over 2 times 5, okay, is equal to 0 plus, again, right, all of this work's becoming repetitive. Those cancel. You get left with pi over pi times 5. There we go. Well, you guys see what I'm talking about, yeah? So, after the second one, so notice how I did this, right? I did k equal 1 first, right? Then I did k equal 3. After this one, I should be able to see a pattern, okay? When I did k equal 5, we kind of knew what it was going to be, okay? So, we have everything done. Everything is all done. Let me scroll down a little bit. So we have asymptotes at these x variables right here, right? So we know that we had one at 1, 3, 5, okay? You can do the same calculation again, right, for the next odd number, but I'll save you the trouble. 7, 9, 11, 13, dot, 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 right? And these asymptotes keep going in the backwards direction too. So I can have -1, -3, dot, 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 dot. Okay? Okay. We have everything we need to graph. So I'm going to go ahead and do it. Okay. So hopefully you guys see there's a dark line here and a dark line there. I'm just going to emphasize them a little more. I know they're not straight, but eh. Okay. We have, come on, there we go. Okay. So these are where my asymptotes are going to be, right here. These are it. So I'm going to sort of split up my x-axis so that I can graph as many of these as possible, okay? When you graph these on paper on your own, right, just have good judgment. You can use two squares to signify one. You can use two squares to signify three. Whatever it might, you can work out the tick marks however you need to, so long as you keep the sort of you keep the spacing consistent. Okay, so what I'm gonna do, okay, is this. I'm gonna make every two lines equal to one. Okay, so that means this is gonna be one, this is gonna be two, three, 4, 5. And I'm going to keep going backwards too in the same manner. So -1, -2, -3, -4, -5. We know where our asymptotes are supposed to be. Okay, so I'm going to grab my red marker. I'm going to make it just a little thicker there. I'm going to draw them in so I know where my asymptotes are. There's going to be one at 1, another one at 3, another one at 5, another one at -1, since I'm keeping the pattern, right? Another one at -3, and another one at 5, way over there. There we go. Okay. Now, I know that tangent, the graph of this in particular, the graph of tangent does this, right? It's got a, there's a, let me come over here, there we go. There's an asymptote, right? There's an asymptote. And the graph of tangent should do something like a squiggle. It should do a whoosh like this, right? That's it. I need to draw my swooshes just in between two of the asymptotes that are present. That's it. So here's the one that I'm going to concentrate on right there, right? And I just can keep going. There's another one. We know that it's going to hit the 0 on the even values, right? You guys see that? It starts down below, hits the x-axis, and then keeps crawling upwards. That's it. Now, I want everyone to notice I'm not taking into account the 1/2. I'm not going to make a big deal about it. Okay, it's much more important that you be able to pick out the asymptotes, right? And just know the general behavior of tangent, okay? Than to really, really graph it nitpicky for the values that we have here. Okay, that simple, that easy. Okay, okay, moving on, moving on. The graph of cotangent. Guess what's going to happen here? Okay, cotangent. Back from chapter 5, we know that cotangent is cosine. Oh, let me revert back to something a little thinner. There we go. Cotangent we know is sine of x divided by, sorry, cosine of x divided by sine of x. Okay? So using the same sort of logic that we did for tangent, right? There's asymptotes. When sine of x is equal to 0, right? Okay? And sine of x is equal to 0, right? At these values right here. When x is equal to, I'm going to start from the middle, right? 0, pi, 2 pi, 3 pi, 4 pi, and so on and so forth in that direction, right? And if you go in the negative direction, right? Negative pi, negative 2 pi, dot, 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 dot. Okay? So, cotangent will be undefined and have asymptotes whenever x is any one of these values right here. So all of these basically will go right here. And I don't want to write them, so I'm just going to leave them. All of these go in here. Okay, it's the same general shape, except for cotangent, right? We flip it. Hopefully you guys see tangent did this. Tangent did this. It went whoosh like that, right? Cotangent goes the other way. It starts up high and then drops down low. Okay? Cotangent has the same big, huge box of information. Okay? And lo and behold, there it is. The list of asymptotes for cotangent are right there. Okay? So we are going to do the exact same thing that we did for tangent. We just get to memorize this equation right here and plug in k values. Okay, so let's move on to the example. Okay, so the equation for general vertical asymptote for cotangent, right, is x is equal to c divided by b plus pi over b, and that's supposed to be a b, times k. In this case, right, k is equal to any integer. So any integer is any whole number, positive or negative. In this case, we don't have to worry about an odd or even value. It can be just any value. It can just be any whole number, 1, 2, 3, 4, 5. Okay, and that's exactly what we're going to do. K is equal to 0. I'm going to start with k equal to 0, and we're going to do this equation, and then we're going to pop out some value. Okay, so x is equal to, if you look at your equation, there is no c, but there is a b. 0 divided by 4, okay, plus pi over 4 times 0. That is equal to 0. Okay, look at it through. It is equal to 0. Okay, next one, k equal 1. Again, just like you probably observed when we were doing tangent, this work becomes a little bit repetitive. Okay, and that's how it's supposed to be. X is equal to, there is no c, so 0 over 4 plus pi over 4 times 1. Multiply all that out, simplify that out, you get pi over 4. Okay? Next one, k equal 2. So notice, remember how I said, this is any whole number, right? So I'm going in order, 0, 1, 2, right? X is equal to 0 over 4 plus pi over 4 times 2, right? This is going to be 2 pi over 4, which is equal to pi over 2. Okay, now I've already seen the pattern, right? But I'm going to go ahead and highlight what we're supposed to be looking for our pattern, right? So I said usually after the second one, you already see what it's going to be, okay? You already see what the pattern's going to be, but I'm going to highlight it, okay? And I'm going to do it slowly so that everybody can catch on, okay? The first computed value that we get is 0. The next one is pi over 4. The next one after that is 2 pi over 4, which reduces down to pi over 2. Okay, in this case, it helps not to reduce it, right? Even though we're going to be using pi over 2 when we graph it, right? It helps not to reduce the 2 pi over 4 because this is what gets us our pattern. So look at what happens, right? 0, it's 0. 1, it's pi over 4. K equal 2, 2 pi over 4. So what should our next value be? K. Let's try it out. So when k is equal to 3, okay, we're going to try this one out. And I make that little line from below a little too long. There we go. X is equal to 0 over 4 plus pi over 4 times 3. If you multiply this all out, 3 pi over 4. There we go. Hopefully you guys see the pattern already, right? So it's multiples of pi over 4. We have everything we need. Asymptotes. Add. X equal, I'm going to start in the middle here, right? 0. Pi over 4. Pi over 2. 3 pi over 4. Pi is the next one, 4 pi over 4. And they go in the negative direction too. So negative pi over 4. Negative pi over 2. Dot, 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 dot. And in the other direction too. There we are. This is where our asymptotes are. At this point, we're all done. Because we now just get to slap these asymptotes on our graph and just start drawing squiggles in between them. Okay, so that's exactly what I'm going to do. So I'm going to thicken up my x and y axis a little bit just to enunciate it a little more. All right there. Right there. I'm pretty sure everybody knows where x and y axis are. That's not a nice straight line. I can make it straighter. There we go, right there. Okay. Okay, so as I mentioned before, you can go ahead and make the tick marks on the x and the y axis, whatever you need to. Just make sure that you make them clear enough to provide something. Yeah, to provide some clarity. Okay. In this case, okay, what I'm going to do is I'm going to do 1, 2, 3, 4. 1, 2, 3, 4. Okay, I'm going to do the same thing in the other direction. 1, 2, 3, 4. 1, 2, 3, 4. Okay, I am going to make each one of these the pi over 4. So this is going to be 2 pi over 4. This is going to be pi over 2. Negative pi over 4. Negative pi over 2. Okay, and these are basically those values right there. Okay. Okay, we know that through each one of these, there's going to have to be an asymptote. So dot, dot, I think I chose the wrong color. Yep, this one. Dot, 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 dot. So these are my asymptotes. Pi over 2 is the next one. There's one at 0. I know this looks weird, but I'm going to draw it in anyway to denote that not only is that the y-axis, but also an asymptote. Okay, there's no harm there. There's absolutely no problem with me doing it. Okay, we have our asymptotes in. At this point, we just get to throw in squiggles in between each one. So cotangent, right, that one's the one that starts up top, squiggles downward, right, as it goes down, right? So this is one of them. Done. Next one. Done. Next one. Notice I'm not making a big deal about the 3 that's in front. Just know that that does a stretch, okay? What I do want everybody to do is be able to give me the list of asymptotes. That's the more important bit. Give me my list of asymptotes and be able to see the pattern that arises when you compute them, okay? That's it. We're done. That's it. That's it. Okay. What comes up next? Quick checks. Quick checks, quick checks, quick checks. Okay? The next 2 graphs. Let me actually put them both. There we go. Bam. Okay. The last 2 that I have to show you are secant and cosecant. Okay. These 2 work a little differently. Okay. I'll explain what I mean when I explain each one of these. Okay. The graph of secant and cosecant are these respectively. You guys see these green strips? So this one's going to be for secant, And these are going to be for cosecant. Okay? Okay. They do have formulas. And I'm going to highlight them here for the asymptotes. You guys hopefully see the asymptotes. The same logic for asymptotes for secant and cosecant work as if we did them for tangent. Okay, here's the one for cosecant right there. Okay, and notice the k, it's any odd integer. In this case, it's any integer, and here it's odd integer. So just make sure that you are doing the correct integers. Okay. Now, what I do want to point out is this. To graph these by hand, we do not use, at least I don't use those equations. I do not use, they're there for you to reach for. Okay, they're actually useful if you want to double check your work. Okay, and like I said, the logic for determining those asymptotes are the same as what we did with tangent and cotangent. Okay, but that is not usually how we graph secant and cosecant. Okay, what I want everybody to sort of draw your eyes to is this. There's that blue line in between for both of these. Okay, for secant, right, that blue line is cosine, right? And for cosecant, that blue line is sine. And you guys remember, right? Secant is 1 over cosine, and cosecant is 1 over sine, right? So this is equal to 1 over sine of x, hence the reason why we have sine here, right? And then secant is equal to 1 over cosine of x, okay? This ends up being the way that we graph secant and cosecant. We end up graphing the associated basic function for it, okay? And then we basically, no joke, we add the bouncy little u's outside of that, okay? So it ends up being, right, we learn nothing new here. We just learn how to graph two more graphs, right, secant and cosecant, based off of their base functions, sine and cosine. Okay, so let me get to an example. So I apologize for this. I am going to call an audible. Hopefully the editing is not horrible. Okay, the audible that I'm gonna shout here is this. I don't want this to be pi. I want it to be equal to 2. Okay. Okay. So now I'm going to continue with this example, knowing that this is now 2. I'm going to leave this 2 here, okay? All right, so as I mentioned from above, right, we don't graph cosecant. What I really am going to graph is this. 2 cosecant is 1 over sine, right? So I'm going to graph 2 sine 2x minus pi over 3 minus 1. So this graph, right, is not the one I'm going to graph. I'm actually going to sort of splotch this out, okay? And I'm going to graph this instead. And then from here, I'm going to graph the actual graph, the original that I have blotted out there, okay? So from here, I'm going to start sort of computing stuff out, looking at the thing that's in the yellow there, right? Midline. We can see that's going to be y is equal to -1, okay? Amplitude. The amplitude is going to be 2, period. We know that the formula for the period, for sine, is going to be 2 pi divided by b. We know that our b is equal to 2 in this case, right? So then this is going to be t is equal to 2 pi over 2. The 2's cancel. Bam. bam, this is, come on, this is equal to pi. So 1 period of our function's got to be pi. Okay? Okay. Let me get rid of that little, there we go. Okay. Next thing, phase shift. We know that the phase shift is going to be the pi over 3, right? Well, let me actually put the variables first. It's going to be my c divided by b. My c in this case, I do have a c. It's that pi over 3, right? Divided by my b, 2. If you compute this out right, let me actually scroll down a little bit. There you go. Pi over, come on, pi over 3, right, divided by 2 over 1, pi over 3 times 1/2, pi over 6. So this graph is actually shifted by pi over 6. Let me put that, okay. I'm going to start highlighting the important bits so we don't lose a track of what we've done already. Okay. So we know that our phase shift, right, is pi over 6. It's going to be in the positive direction. So looking at our phase shift, we know that we have to move it pi over 6. And notice, let me scroll up, that sign is negative. So we have to move it into the positive direction. So our phase shift is pi over 6. It's got to be in the positive direction. So that means our graph starts at pi over 6. Okay? Now we need to find our stop. Okay? Our stop should be the pi over 6 plus 1 entire period. Right? So plus pi. And if you compute this out, right, this is going to be 7 pi over 6. If you do your common denominators right, that's what you're going to get. All right. So now, we've got everything we need. I'm going to actually highlight the stuff that we need. There we go. Okay. So now, I'm going to attempt to draw it. Okay. So I'm going to start by sort of emphasizing my x and my y-axis. I'm going to, oh boy, how about I start drawing a straight line? There we go. Bam. Oh boy. I wish I could put a ruler down. I swear to you. That's good enough, right? Okay. Bam, 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 bam. So we know that these are my x's and these are my y's. Okay. I am going to start throwing down my tick marks on my x-axis. Okay. And what I'm going to do is I'm going to do every 2. Like I said, you can go ahead and do these tick marks however you see fit. Okay. They don't have to be by 2s. They can be by 3s. They can be by 1s if you wanted to. Okay. I'm going to do it by 2s so that it gives me enough space. That's it. So we can sort of graph one out. Okay. Each one of these tick marks is going to be pi over 6. So pi over 6 here, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. Hopefully you guys see me counting these out, right? 8 pi, whoa, that's a nasty 8. 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi, 11 pi over 6, 12 pi over 6, and 12 pi over 6. We know that 12 pi over 6, that reduces to 2 pi. So I can go ahead and you can reduce these if you see fit. Okay, I'm just trying to maintain a pattern so that everybody sees what I'm trying to do. Okay, now, because of these two things down here, okay, we know our graph has to, and look at me go. I didn't even notice I did pi over 2 here. That's supposed to be pi over 6. Okay, because of that thing that I circled down in the bottom right, I know my graph has to start at pi over 6 right here, at end at 7 pi over 6. You guys see why it's easy or why it's nice to have these sort of points sort of laid out for you, right? Okay? Okay. So actually, I'm going to go ahead and I'm going to do a line here and a line here just to give us our boundaries. Got it? Okay. We are trying to graph. Let me actually scroll out a little bit. We are trying to graph this right here. Okay? We have all the information for it. Okay? So now I'm going to try to slap this down, yeah? And what I'm going to do here is I'm going to do, is that going to be enough? Not going to be enough. I'm going to, there we go. That's going to be -1, -2, 3, 4. This is going to be -5. Okay. And then this is going to be 1, 2, 3, 4, 5. Okay. Okay. Here we go. Follow along. Okay. We have an asymptote. Or sorry, we have a midline. That midline is this. At y equal -1. That is that -1 from our sine graph. Okay. Okay. Let me actually let me rewrite our boundary sort of lines just so we know, just to keep ourselves straight, right? Okay. This is a positive sine graph, right? So it'll look like this. It'll look like that, right? As opposed to the other one that goes like this, right? That one's the negative one. So we need this one. Okay. Okay, let's start sticking that in, right? We know that it has to start here and end here, okay? It's got to cross halfway in between, so this is why it's nice to have it so spread out. Halfway in between looks like it'd be right there, okay? The amplitude is 2, so that means it's going to go up 2 and down 2. So the high point is going to be halfway between, so that's going to be right here. I'm going to draw the dot right there. And then the other one's going to be halfway in between. I'm going to draw the dot right there. Hopefully you guys see what I'm doing. Okay. And I am going to add in our, I'm going to do it in a thick blue, well, a little thinner. But what I'm going to do is I'm going to draw it in, actually, before I do that, hopefully you guys see what's going to happen from here. Remember, I can graph these out a little further, right? I can keep going in terms of the pattern for the points. So I'm going to do, my next point is going to be 2, 3 here. My next point after that is going to come back down to here. My next point after that one's going to come down to here, right? Hopefully you guys see the pattern, right? And I can keep going backwards, right? So down here, up here, okay? Now I'm going to thin out my marker. Okay, I'm going to draw the segment that's in between these two, in between here and here, okay? And what I'm going to do is I'm going to draw it in as a dotted line, okay? Okay, I am drawing in the corresponding sine curve. Okay, there it is. This dotted line is the graph of this thing right here. Now, that is not what we wanted to graph. We wanted to graph this. We wanted to graph the cosecant graph. Okay, now I'm going to scroll back up to the 2. Okay, notice how this works. Hopefully, if you guys see, here's my midline, right? Here's my midline. At all the points where it crosses the midline, you have an asymptote. Yeah? Same thing here. Okay? And all the points that are all the points that are the tippy top or the bottom of sine and cosine, right? That's where you have your U shape. Yeah? Okay. That is exactly the plan we're going to follow to graph all the rest of the stuff that we need. So I'm going to go back down to my graph. Okay. I'm going to draw in the asymptotes now. Okay. You guys see that this point crosses the asymptote or the midline. So there's one there. There's one there. There's one there. There's one there. And they just keep going, right? You guys see that? Bam. Okay. All that's left is to give the U shapes that happen at the tips, right? And at the troughs. That's it. So I'm going to make that real thick. And now these are the final graphs. So there's going to be a green portion right here. There's going to be a U shape right here. There's going to be a U shape right here. There's going to be a U shape right here. Again, I'm not making a big deal about how well you graph the U shapes, right? But I do need a very, very particular, right? A pretty solid notion that you are graphing based off of the sine graph or the cosine graph. Okay. There it is. So my green, whoa, those green U shapes are the final answer for this graph. Okay. This has a lot of work. Okay. Make sure you write down all your steps. It's easy to get mixed up in the small little minutia calculations that you have, right? So keep your thoughts straight, write everything down. And as always, you can double check this using Desmos. Okay? Okay. I believe after that, well, actually, no, we have one more. Okay. Let's do it again. Okay. So for secant, I don't want to graph secant. I want to graph the cosine. So I'm going to graph y is equal to -3 cosine. 1/4 x minus pi over 6 plus 1. So I'm going to graph this instead. I'm going to graph this instead. Okay, I still want to graph this, right? But I'm going to do that at the end. So I'm going to, like I said, I'm going to blotch this out. So let's start with the calculations for this one. Okay, midline. Looking at this, y is equal to 1. The amplitude is going to be 3. Okay, period. The period is going to be, the formula for it, right, is going to be equal to 2 pi divided by b. We know that b, right, in our case, is 1/4. 1/4. So my t is going to be 2 pi divided by 1/4. And if you compute this out right, 8 pi. Okay? Phase shift. It's going to be c divided by b. Okay? Pi over 6 divided by 1/4. If you compute this outright, it is going to be 2 pi divided by 3. Okay, follow along here, okay? I'm going to do the start and stop now. We know that this thing is going to do, we have a start, okay? This starts at whatever our phase shift is. So it should start at 2 pi divided by 3. And since this is negative up here, right, since this in particular is negative, right, we have to move it toward the positive. So that's why it's positive 2 pi over 3. Stop. The stop portion is going to be the start, so 2 pi over 3, okay, plus the 8 pi of a period. And if you compute these outright, 26 pi over 3. Don't hate me. Don't hate me yet. Please, please. Okay? We have all our important bits. 8 pi of the phase shift, start, and stop. Okay, so I am going to now attempt to graph it. Okay? Again, like I said, ain't no shame. Write it all down, write it all out. Whoa. It's better to write it out than not. You don't want to have it just sort of in your head. That's how people go insane. Please write it down. Okay. X and Y. Okay. Like I said, you can grab your X values, your X axis, and divide them however you need to. Okay. In this case, what I'm going to do is I'm going to divide my X axis where 1 square is going to be 2 pi over 3. There's going to be a reason for it, right? So this is 2 pi over, let me thin that out a little bit. This is going to be 2 pi over 3, okay? So that means 2, 4, 6, 8, 10 pi. 10 pi over 3 is going to be there. 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. 20 pi. Let me thin that out a little more. Actually, let me keep going. This is 30, 32, 34, 36, 38, 40. 42, 44, 46, 48, 50. Okay, so I'm counting out by 10 pi over 3. So this is going to be 20 pi over 3, 30 pi over 3, 40 pi over 3, 50 pi over 3. Okay, now you're probably asking yourself, why the hell did he do that? Okay, it's easier now to count out the amount that we need. We need to, our graph needs to start here, right? It has to start at 2 pi over 3 and end at 26 pi over 3. 20, 22, 24, 26. It has to end here. Okay. We now know our borders for our graph, our cosine graph. Okay, so now I'm going to go ahead and try to attempt. I'm going to actually leave these, but I'm just going to make them shorter. 20, 22, 24, 26. Bam. Okay, I'm going to actually try to attempt to throw down the cosine graph. Okay, the amplitude is 3. The amplitude is 3. The midline is 1. Okay, and it's going to be a negative cosine, so negative karate again. Okay, here we go. Let me do the midline first. I'm going to go ahead and leave. Can I make it? Nope, that's as thin as I want to make it, actually. That is my y equal 1. Okay, I need to go up and down this amount, my 3, right? So if you take a look, right, my midline is 1, so this should go up to 4 and down to -2. This is going to be a negative cosine graph. So I need to do this, since it's going to be a negative cosine graph. 1, 2, 3. Okay? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces, right, for one period. So halfway across should be where it goes to tippy top, right? So 1, 2, 3, 4, 5, 6. 1, 2, 3, right there about. And then it should drop down, right? Back down to right here. Okay, halfway between each one of these, right, these 2 points, it should cross the x-axis. So there was 6 spaces, so 3 spaces. So 1, 2, 3, right there. It should cross the x-axis. And then 1, 2, 3 should cross right there. And now I can repeat. I can just keep repeating my points here. So 1, 2, 3, it should cross the midline, right? And then 1, 2, 3, it should be tippy top. 1, 2, 3 over, it should cross the midline. 1, 2, 3, it should be down at the bottom again. 1, 2, 3 should cross the midline. Okay, I am going to do like I did before. I'm going to connect these dots using a dotted line. Here we go. There we go. Okay. And just like before, wherever it crosses the midline, right, we have asymptotes. Yeah, that's the right color. There we go. One right there. One right there. One right there. One right there. And then one right there. We have everything. We have everything we need. So at this point, I'm going to start adding in my green. I'm going to get rid of my barriers here, the space pen. Okay. At this point, I'm going to add in the rest. I'm going to add in the actual graph for secant, right? At every tip and every trough of my squiggle, I'm going to have a U shape. I'm going to make it, yeah, that thick. I'm going to make them green. So, bam. Here's another one. Here's the other one right here. Here's the other one right here. Here's the other one right here. And so on and so forth. I'm not going to make a big deal about you know, if you don't make the U-shaped look correct. Okay, but I do, like I said, I do need to see that you give some semblance of the base graph that you're going to be referring to, right, when you graph this. Okay? All right. I think after this, for sure now, yep, lecture questions. Okay. Try these out. Okay. Like I said, write down all the information that you possibly can. Okay. It's better to have it written down than floating in your head. Okay. If there's any questions on the material that I covered in this section, ask me during our quick check time or come by my office hours. Okay. Besides that, happy studying.